All right, one more thing I would like to do before we actually talk about, I got about 6 different operations on the linked list that I would like to go over with you, like a different algorithm. I think we should really go over before you can apply. Then to really creatively create your own algorithms on singly linked lists. Before that, let me show you how to use Debugger to trace the code. Let me now switch to Eclipse. Right, so the source code I made available to you is called example string linked lists project over here. If you expand the project, well, import it to your Eclipse and then expand the projects, you will see under string SLL, we got node, we got singly linked list. That makes sense. These are the only 2 classes we spoke about. And also I supply some JUnit test cases to you. Make sure you read them and make sure you understand them, and you will be able to write some of them. Maybe for your programming assignments, or maybe for your programming test later, or even exam. You may be asked to write test cases, right? That's something we assume you learn about in the earlier OOP course. All right, so I'd like to show you how you can use the debugger to trace the singly linked list construction. It's pretty easy. And you can definitely look at the source code. It has very good, very high correspondence to what we spoke about in the lecture. But let me just leave that to you. But I want to trace this one specifically together with you. It's test SLL 01. All right. You can see this part over here is about the code to really construct a chain of nodes. And then after that, we actually will, sorry, only this part. So this part over here is going to construct a chain of nodes. And then we're going to set the beginning of the chain to be the head of the list, and then we have some assertion over here. That's now, and also that one is really using the get first and get next, get next, right? That's something I also spoke about just on the iPad, right? Let's now try to trace them. I'll show you different ways to trace it. Maybe I'll have 2 runs together with you. So put a breakpoint in the beginning of the test case, and then I'm going to right click on test string singly linked list. You want to say debug as JUnit test. And then it might just prompt you to switch to the debug perspective. Do so. And then you can see the execution will pause at line number 60, right before we actually execute this particular line over here, right? You got options over here. If you want to go directly to see how the chain of nodes will look like, you can simply put another breakpoint over here. You can see if I put a breakpoint over here, and then I can say step return over here. I'll do that in a moment. If you click on step return right away, so that means we're gonna skip. We're gonna still execute these 3 lines, but without pausing at them line by line. We're not gonna do that. We can go directly to the final outcome of executing these 3 lines by putting the breakpoint immediately after. Let's do that first. Okay. If I say step return over here, you can see now we actually got under variables panel over here. We got Tom, we got Mark, and we got Alan over here. Okay. And remember our setup. Let me just remind you about the diagram over here. You can see here, just for example, there's something you can definitely double check on Eclipse over here. I'll show you one example. You can see Alan, it's a reference variable storing some address over here, right? And also you can see Mark is also has some address over here. Let's now try to write it down. Okay, it's important to see exactly to really make use of Eclipse debugger as much as possible. If you first of all, let's start with the address for Mark, right? You can see Mark, the type is actually a node, and this is package name and also the class name, and this will be the address, right? For the 31. Okay, let me write it down. You can write it down as well, but exactly what this address is may be slightly different when you actually invoke your debugger, but it's definitely important to keep track of it. So let me write it down, and then I'll switch to iPad in just a moment. So for the 31, 67 F4. All right. Let me see one more, and then now remember the address over there. And if you see Tom, and then you can see every object can be decomposed into 2 compartments over here, right? And the Tom next is actually none, which makes sense because you can see Tom actually is the last node over here, the last node over here. So the next should be actually simply just none. That one is okay. However, what I want to show you is Alan. All right. If I simply go to Alan over here, Alan.next is actually pointing to this particular object of this reference over here. Of course, you can expand it further. You can see that one is really referring to Mark, which should be the same address as a Mark over here. Let me show you on the Eclipse first. If you look at this address over here, next, this is the address 40317F4, right? And if I click on the Mark over here, you can see the address doesn't change. So that means they are the same address over here, right? It's very important, right? But I already did some favor for you. You can definitely try to write down the address over here. You will see that the address of Mark will be the same as the address of Alan.getNext. It will be the same. You can also double check this. Let's go back to Eclipse. You can double check it by going to expressions over here. And let me just remove these two earlier expressions. Let me just remove them. What I can do is I can say Alan.getNext over here. And also I can also put Mark. If I see the address of this and the address of this, they are the same. Or I can just make it more explicit. I can say Alan.getNext equals Mark. True. All right. It's very important about the reference aliasing that I have been mentioning. All right. And I will give you one more walkthrough over here. You can definitely see Alan will be the beginning of the list, and then Mark, and then Tom, right? Somehow the variables panel wouldn't sort them in that way. So what I can do is I can simply put over here. I can put Alan and also Mark and also Tom over here, right? So you can see Alan over here has the next, which points to Mark. Mark also has a next over here, which points to Tom. And the next of Mark, sorry, the next of Tom, which will be the last node. In that case, the next reference for the last node should be just null. And similarly, if you see the Mark over here, the next will just be Tom, and that's it, right? So it's basically like this. Either you can maybe start to see the chain of nodes from over here, in which case you will see next, and then next, and then next. Or you can start a chain of nodes maybe from here to inspect, in which case you will see next, and then next, and this last next will be just null. Or you can just start a chain of nodes just from here, in which case the next will just be null directly, right? And of course, in the diagram, in case you are wondering about it, this part over here should definitely be null, right? And this one over here should definitely be null. All right, let's now go back. All right. Okay, so wrong way. Okay, assuming that you're okay with this, and let's now talk about the list, right? So now we are pausing at line number 64 right before we create a list. So that's why under variables, you don't see the list. But if I say go over, I can say step over. In that case, you can see the list over here. And then you can see the head is simply just null. And for the size and tail, so these are the two attributes which I will introduce later in the lecture. So, but for the source code I gave to you, that's a final version. That's why you're seeing this. But don't get confused. Let's focus on the head over here, which is simply just null. And as soon as I say set head, right? That's the call by value tracing we talk about. If you can definitely step into if you want to. If you step into, you can see now the head at the moment is simply just null, but we're gonna set it to be n, and n call by value is going to point to basically Alan, right? If you look at n over here, the element here is just Alan, right? That will be the chain of nodes that we have been talking about, right? It's exactly what's happening over here, right? If I say step over, you will see the head right now. This will be the singly linked list. The head will just be pointing to that Alan node over here. If you expand the head, you can see Alan, and then Mark, and then Tom, and then null, right? The head has been set to the beginning of the chain of nodes. That makes sense, right? I can say step over, and then now you got the various assertion over here. You can definitely check for every one of them, right? And you can also try in the expressions over here. Let me try one more thing for you. For example, you can say, let's say, how do we get the head of the list? You can say list.get first, right? So that will give you the head, which will be Alan. So what you can do is something like this. You can say the list.get first. So this will basically give you the node which denotes Alan. And you can also try list.get first equals. Is it really referring to the same objects as Alan? It is, so that's why it's true. But if you try another one, if you say list.get first, let's say dot get first equals, let's say Tom. Sorry, not get first. I meant to say get next. All right, this one is actually false, right? This will be some little exercise for you. Based on the diagram, why would this be false, right? That's something I want you to go back to the diagram and see why it would be false, right? That's something I'll leave to you as an exercise. That's correct answer, but you want to see why. And you can definitely see other assertions over here. I'll leave you to really go over one by one if you wish. All right, that's run number one. Run number two, let me just go back to debugger over here. So what we just did in the earlier run, we simply skip all these ones. Actually, not to be executed in slow motion. But now, if you really want to see exactly how each one of them will work to see the connection is being built, you can definitely do the following. You can simply just step into, for example, line number 60. That's where we are at. You can step into, and we are building this particular node, and we are trying to say string will just be Tom, and n will just be null. Right? So we are basically building this last node over here for approach number one. So we are building this particular nodes. Right? We're setting Tom to be the elements and null to be the reference. Right? That's what we're doing. All right. If you do that over here, do that, and you can see that this context object will just be the node. Element has been set to Tom, and also next has been set to null. All good. So all we have done is only this part over here. And then the next line, which I'll show you very briefly, is to build this, create this mark node. At the same time, we want to build connection to Tom. How do we do that? Very consistent to how we set in the tracing. Let me just say step over. So now we are done executing line number 60. If I step over, how do we execute this line over here? And when we create a node over here to be stored in mark, not only that we want to set the element to be mark, but also the next node should be wherever Tom is pointing to, right? If I say step into, that's what I meant, step into. So that will actually let us go line by line into the constructor. You can see the element is going to be mark. So we are now creating this particular node over here. That's what we're doing. Element should be mark. Next should be wherever Tom is pointing to. All right. So what we're doing here is you can see the end over here is wherever Tom is pointing to. That's a Tom node over here, right? And you can definitely try to do line by line as we said on the paper. After this, if you look at the current node, which is mark, the current node is mark, but now its next node has been set to Tom, and Tom itself has the next node being null. So what we have set up is essentially is this part of the chain over here, this part, except for the first one over here, which will be done in the next line. All right. All right, let me now say step over. All right, you can execute that as well and then confirm, right? That's a very important exercise for you to do, just to make sure you can really connect what we did on the paper for tracing and also what it can be seen for its correspondence on the Eclipse debugger. Both are important. Right, let me say I'm done, and let me now stop it and then go back to the Java perspective, right? There will be some parts of the source code that I want to go over with you later. All right, let's go back. All right, let's now go back to the slides. I believe that's about it. And let's now talk about the various operations on syncly linked list.